Hello everyone, my name is Mrs. Anthony and I teach 5th grade at Pass Road Elementary in Gulfport School District. Today we are going to be talking about the different types of forces. So we will be focusing on 2 standards today. The first standard is P.5.6.3, which states that we're going to develop and use models to explain how the amount or type of force, both contact and non-contact, affects the motion of an object. The second standard that we're going to focus on today is standard P.5.6.4, which says that we're going to plan and conduct scientific investigations to test the effects of balanced and unbalanced forces on the speed and direction of objects in motion. So, what does all that mean? Well, to simply put it, our goal today is to understand the different types of forces and how they affect the motion of different objects. So the essential question that we want to keep in our minds as we go today is, what types of forces do we see in our daily lives? Because forces are all around us. They are constantly happening, even if you don't think so. So let's get started. So before we get into our lesson, I want to focus on 5 key terms that are going to be really important to us. We're going to see some of them in our passages. We're going to hear some of them in our videos. So it's really important that we have a strong understanding of what these words mean. So our first word is force. After all, we're talking about the different types of forces. So we have to know what a force is. So simply put, a force is a push or a pull on an object. So when you pull a door open or when you push a door closed, you're applying a force and causing that object to move. The second term that I want to talk about is contact force. A contact force happens when 2 or more objects or bodies touch or contact each other and cause movement. So imagine here on my picture, we don't even have to imagine. We can see, think about a friend riding on a bike or on a tricycle or something like that, and you have your other friends giving that person a push. They are physically touching and making contact with that person and that object and making a motion happen. They're applying a contact force. Now, a non-contact force happens because some forces don't need to touch the things that they are affecting. So think about gravity. We don't see gravity, we don't feel gravity, but a force is being applied upon us because it's keeping us here safe on the ground. So next, we have the last 2 types of forces that we're going to talk about today. The first one is a balanced force, and that is when 2 forces are the same strength, but they're acting in opposite directions. So no movement happens. So think about 2 big, strong football players, and they are pushing against each other. They're the same weight, they have the same strength, and so if they're pushing against each other with the same strength and force, nobody's gonna move. They're just gonna be standing in one place pushing. That is an example of a balanced force. Now we have unbalanced forces. So say we have 1 strong football player and 1 that's a little less strong. Maybe they just got on the team. And so when they go up against each other, it's most likely that the bigger person is going to apply their force and movement is gonna happen. So unbalanced forces are when a push or a pull causes an object to move. So an easy way to think about it, contact forces making contact. Non-contact, no contact. Balanced forces, no movement. And unbalanced forces equal movement. That's a simple way that I like to think about it. So we're going to read a short passage and talk about a few questions just to kind of check our understanding on these key concepts that we've just looked at. So read along with me. Force and motion. Forces are found everywhere. A force can be a push, a force can be a pull. We just learned about that in our vocabulary. They cause objects to change their motion. A force can be as big as the pull of a star on a planet. It can be as small as a girl raking leaves. A push is a force that moves objects away. A pull is the force that moves objects closer to something. A force can change the motion of an object. It can start its movement, it can change its speed, it can change the direction of its motion, it can even stop it. Friction is a force that slows or stops motion. Two surfaces that are touching must slow or stop in motion. Rubbing your hands together is an example of friction. Friction can happen between any two surfaces. Rough surfaces have more friction. Smooth surfaces have less friction. Friction can be very useful. Writing is friction. The friction is between your pencil and your fingers. You would not be able to write without friction between the two. Friction that takes place between the air and objects is called air resistance. Airplanes have a sleek design. This is to help the air slide over them smoothly. This makes them move faster. Gravity is another type of force, a non-contact force if you remember our vocabulary. It pulls objects toward each other. Gravity acts on objects at a distance. Friction acts on objects that are rubbing together. So that's a contact force. The gravity of Earth holds the moon in orbit around the Earth. Mass is the amount of matter in an object. Objects with greater mass have stronger gravity. Earth has a greater gravity than the moon. It has a greater mass. Gravity is the reason why things fall. So again, gravity, we don't see it, we don't feel it, it's not touching us, but it's a force that is happening to us. So now that we've read, let's look at our questions. Number 1 asks us, what is a pull? A, moving objects away. B, moving objects closer. C, friction. Or D, changing to faster speed. I'm going to go with B, because if we look in paragraph 1, it tells us right there, a pull is a force that moves objects closer to something. So that is choice B. Number 2 says, which is the best example of gravity? Well, let's remember that gravity is a non-contact force, so nothing is touching, nothing is making contact. So let's look at our choices. A, pushing a box across the floor. B, a river flowing downhill. C, raking leaves. Or D, rubbing your hands together. Well, when I rub my hands together, I know that they're touching, and that's a contact force, so it can't be D. Raking leaves, I have to use the rake to pull the leaves closer, so again, I'm making contact. A river flowing downhill, well, nothing is necessarily making contact with the river, it's just flowing. So I think that may be our choice, but let's look at A. A says pushing a box across the floor. Well, if I'm pushing something, I know I must make contact with it. So we can eliminate A as well. So our answer is B, a river flowing downhill. Number 3 says, why do things fall? Well, I remember in the text in paragraph 3, it tells me that things fall because of gravity. And I know that gravity is pulling objects towards the ground. So let's look at our choices and see which one is the best fit. A, the object is being pulled to the ground. Look at that. Sounds familiar. B, the object is being pushed into space. C, they have a sleek shape. Or D, the distance the object travels over time. I'm gonna go with A. That's the most sensible answer. I know that gravity makes things fall and come to the ground, just like A says. Number 4 says, what is the best example of a force? Let's see. A push or a pull, holding a pencil, gravity, or all of the above. Well, a push or a pull, that's a force. Holding a pencil, we know that that's how we write. We need forces to write. And gravity, remember we said that that is a non-contact force. So I'm going to go with D, all of the above. And finally, number 5 says, which is a true statement? Let's see. A, lighter objects have greater gravity. B, heavier objects have greater gravity. C, heavier objects have less gravity. Or D, none of the above. Well, this one we have to think a little bit about because I may not be able to find the exact answer in the text, but in paragraph 3, it does tell us that the gravity of Earth holds the moon in orbit around the Earth. Mass is the amount of matter in the object, and objects with greater mass have stronger gravity. Earth has a greater gravity than the moon. It has a greater mass. So I can make the inference that when something is heavier, it has more gravity. And I'm going to go with choice B. Heavier objects have greater gravity. Paragraph 3 helped me out with that one. All right, so I hope you got these answers correct. Hopefully I got them correct as well. But we are going to go ahead and finish up with 2 videos that just go back over the different types of forces. Hope you enjoy. First, we're going to look at contact versus non-contact.
Hi kids! Today we will learn about force. So let's get started. First of all, we need to know that nothing can move unless some force is applied on it. Trees sway. We run, walk, move any chair, or vehicles move only when some force is applied to them. The trees move when wind or air pushes the trees. We can run if we apply force, that is, we push ourselves forward. We can move a chair by either applying force to push it or apply force to pull it. Vehicles move when lots of force is applied through the engine of the car on the tires of the vehicles to move. That is, nothing moves unless some force is applied to it, and every force is either push or pull. Push. It can cause movement away from one pushing it. And pull, it can cause movement towards the one pulling it. Let's see it with examples. Closing the door of the refrigerator. What force can close the door? We will push the door of the refrigerator to close it. Opening of refrigerator. What force can open the refrigerator? We will pull the door to open it.
Tootway has thousands of animated videos on math, English, and science to clear the core basics of these subjects.
Running a bicycle. What force is required to run a bicycle? You require to push the paddles to run a bicycle. Moving a chair. You need to push the chair away from you or you pull it towards you. Running also involves pushing yourself forward. Kicking a ball. Kicking a ball requires you to push the ball hard to move it. So kids, no matter what is the movement, in every movement of every object, either pull or push moves the object. We have seen that everything moves with some force, and it's either push or pull. Now let's see what force can do. Force can cause an object to start moving. Force can cause object to stop moving, and can also cause an object to change its direction. Here is your toy car. You can push it forward. You can pull it back. You can change the direction of movement of your car. You can stop your car. We learn that every force is either a push or pull. But we can also categorize force depending on whether a force is resulting from a contact between two objects, or there is no contact between two objects. Now let's see what our contact force is. Contact force is the force in which an object comes in contact with another object. They also direct forces. Examples: pushing a car, pulling a rope, opening a door and closing a door, kicking a ball, running a bicycle. In all these examples, force is being applied and there is a contact between two objects. Only then the object moves. You are not opening the door without touching it. You are not kicking the ball without touching it. Examples of contact forces are friction, normal force, tension, buoyancy. Now let's learn what are non-contact forces. The forces that move objects without coming in contact with the objects, or they are invisible forces. That is, it is a force applied by an object to another object, which is not in direct contact with it, so they are called invisible forces. Examples: gravity. A force that causes a pencil to fall on the ground is gravity. It is the pull of the earth that causes the pencil to fall on the ground. Leaves fall from the tree to the ground. Why? Because there is a pull from the earth. Another example of non-contact force is magnetic force. Here is a pin. Now, bringing magnet closer to it. The magnet attracts the pin. That is, the pin is moved towards the magnet without any contact between the pin and the magnet. So there is an invisible or non-contact force acting here. More examples of non-contact forces are nuclear force, electrostatic force. So kids, today we learned about forces. Now go ahead and take a quiz to learn more. Bye-bye.
All right, everyone. So we just watched that quick video all about what a force is and contact forces versus non-contact forces. So again, think about contact, making contact. You have to touch. Non-contact, I like how she said invisible forces, because we can't see them acting on different objects or even ourselves. So we know about non-contact and contact forces. Now let's look at balanced versus unbalanced forces. Enjoy.
Take a look at what happens when forces are unbalanced. Welcome to Moo Moo Math and Science and balanced and unbalanced forces. Newton's first law of motion states that an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. But how are balanced and unbalanced forces different? Balanced forces will cause no change in the speed of an object. Balanced forces acting on an object in opposite directions and in equal strength, as shown in the arrows below, do not cause a change in the speed of a moving object. Objects that are not moving will not start moving if acted on by balanced forces. Remember, forces have a magnitude and a direction. Unbalanced forces are not equal, and they cause the motion of an object to change. When two unbalanced forces are exerted in opposite directions, their combined force is equal to the difference between the two forces. The magnitude and direction of the net force affects the resulting motion. This combined force is exerted in the direction of the larger force. Let's take a look at some real-world examples. The forces acting on the red pull balls are balanced. The downward force of gravity is equal to the resistance force of the pull table. When the white ball strikes the red balls, the forces are now unbalanced and they move in the direction of the force. The forces are balanced on the weights. The downward force of gravity is equal to the resistance force of the yellow rack. The weights do not move. The weightlifter exerts an unbalanced force upward, and the weights move in that direction. The forces on the tennis balls are equal. They are not moving. When the tennis balls are struck by an unbalanced force, it causes them to move. The resistance force of the car is balanced with the downward force of gravity. The car jack exerts an unbalanced force on the car upward, and the car moves in that direction. The car is at rest, and all forces are balanced. When the car that is moving strikes the car at rest, then the forces now are unbalanced, and the car moves in the direction of this force. If you'd like to know more about unbalanced or imbalanced forces, this playlist will help. And as always, thanks for watching, and Moo Moo Math uploads a new math and science video every day. Please subscribe and share.
So now we've watched our video on balanced versus unbalanced forces. The key thing to remember, balanced forces, no movement. The forces acting against each other are equal. Unbalanced forces happen anytime there's movement. An unbalanced force is acting on that object. So I hope after this lesson you can differentiate between the many types of forces, and I hope you enjoyed today's lesson. I will see you next time. Thanks for watching. Bye.